Okay, so in this video I'm going through the Chapter 6 review. The first two give me two functions and wants me to describe the following characteristics. I'm going to go to y equals and type these in so I can see what these graphs look like. So this one looks like this. My domain, it might be given to me as negative infinity to positive infinity, or it can also be all real numbers. This gets close to the y value of 0, but it goes up forever. So this is 0 to infinity with parentheses, or another way is y is just greater than 0. My y-intercept is where it's crossing the y-axis. On here it's crossing at 3, so that's going to be 0, 3. And my asymptote is the line it's avoiding. This one is y equals 0. So same thing for number 2. This one is 0.25x to the... Okay, so this one looks like this. My domain is still positive infinity to negative, or negative infinity to positive infinity, or all real numbers. My range is based off of this number, so negative 4 to infinity, or y is greater than negative 4, depending on the notation it wants. My y-intercept is where it's crossing the y-axis. Here it looks like it's negative 1. I can go to second table and look at my x value of 0 to double check. So 0, negative 1. If I go back to my graph, my asymptote is the point it's avoiding. So this is y equals negative 4. This one wants me to deposit $13.50 into an account that pays 4.3% every year. Find my balance after 3 years. The formula for this is y equals a times 1 plus r over n to the nt power. So this is my a. This is, just kidding, I think the formula is p. So this is my p. This is my r. I divide by 100 to turn it into 0.043. This is my time, and then depending on these are my ends. So annually is 1, quarterly is 4, daily is 365, semi-annually is 2, monthly is 12, and continuously I actually use a different formula. I use p times e to the rt. So I'm going to go ahead and plug all of these in. I'm going to have 1350 times 1 plus 0.043 over 1 to the 1 times 3. I want to go ahead and type this into my calculator. This one gets me 1531.75. Then semi-annually is plugging in 2. This one gets me 1533.78. Remember, I'm doing 2 decimal places because this is money. Next one I plug in is 4. This gets me 1534.82. Monthly, I want to plug in 12. This one gets me 1535.53. My next one, I'm plugging in 365. Oops. So this gets me 1535.87. And then continuously I'm using a different formula, so it's 1350 times e to the 0.043 times my time which is 3. This one gets me 1535.88. Okay, the next one wants me to expand the following expressions. Remember, each of these things are different parts, so I have ln of 7 plus ln x to the 5th minus ln y cubed, because things on the bottom get subtracted. Then if I have exponents, I want to go ahead and bring those out in front. So I really have ln 7 plus 5 ln x minus 3 ln y. Again, 3x and y are all separate things on b, so this is log base 8 of 3 plus log base 8 of x plus log base 8 of y cubed. My exponent goes out front, so I have log base 8 of 3 plus log base 8 of x plus 3 log base 8 of y. And then again, 3, y, and x are separate here, so that is going to be log 3 plus log y, because those are on the top, and then minus log x, because that's on the bottom. These ones I want to condense, so exponents go back to their numbers. This is going to be log 7, 4 cubed, plus log 7, 6, minus log base 7, 8. 4 cubed is 64. I'm going to leave everything alone for now. Then I want to put this all together, so I have log base 7 of 64 times 6 divided by 8. This one simplifies to log base 7 of 64 times 6 divided by 8, 48. Over here, put my exponent back. Log base 2 of 12 minus log base 2x squared. Put it together, log base 2, 12 on top, x squared on bottom. Over here, exponent goes on top, so I have ln x squared plus ln 2 to the 5th minus ln 8. 2 to the 5th is 32. Oops. Then I put it back, I have ln x squared times 32 over 8. I want to simplify this. This is ln 4x squared. Okay, this next one tells me the population of a city is 25,672. The annual growth rate is 0.8%. Write a population to do it after x years. This formula is going to be y equals a times b to the x. So for a, this is going to be y equals 25,672. Because it's a growth rate, actually I lied about the formula. This one is y equals a times 1 plus r to the t. If it was decreasing, I'd subtract r. Plus 0.08 to the t. What's the population after 5 years? So I'm going to plug in 5 for my t. Go ahead and type this in. 25,672 times times 1 plus 0.08 to the 5th power. Did it wrong. Gets me 3,720.6. But I'm talking about people, so I want to make this a whole number. 3,721 people. How long does it take for the population to double? I don't know what that number is doubled. That's not a nice one. So 5,134 equals 25,672 times 1 plus 0.08 to the t. I'm going to go ahead and solve this by hand. Remember, the other way to do this is to graph it. So first thing I want to do is divide both sides by 25,672. This gets me 2 equals, I'm going to simplify the stuff inside parentheses 2, so that's 1.08 to the t. To solve this, I am going to use logarithms, so it's going to be log base 1.08 of 2, equals log base 1.08 of 1.08 to the t. the log base 1.08 and the 1.08 cancel out. So I have t equals log base 1.08 of 2, which I can type into my calculator. I go math, it's choice A. This gets me it's about 9 years. Okay. On the back side, these wants me to find the inverse, so I'm going to switch my x and y. Then I want to isolate my y, so first step here is subtract 3. I have x minus 3 equals e to the y. To get rid of my exponent, I rewrite these as ln, because log base e is ln. The ln and the e cancel out, so I just have y equals ln x minus 3. Over here, switch them again. If there's no log base written, remember it's by default 10, so I'm going to write 10 with an exponent of x, 10 with an exponent of log y plus 3. My 10 and my log cancel out, so I have 10 to the x equals y plus 3, subtract 3, y equals 10 to the x minus 3. Over here, switch the x and the y. Then, to get rid of my log base, I first have to isolate it, so I'm going to subtract 7 on both sides. Then, to get rid of it now, I have a base of 2, and everything becomes my exponents. My 2 and log base 2 cancel out, so I get y equals 2 to the x minus 7. These ones want me to find the values. I can type this into my calculator. I'm going to go stat, edit. I'm going to clear out my list if there's numbers there. So I have 0, 1, 2, 3, 2, 6, 18, 54. I go stat, calc. This is exponential regression, which I think is 0. Go all the way down to calculate, press enter, and it gives me this. So my initial value is my a, so that's 2. My growth factor is my b, that's 3. The percent change, so I want to do 3 minus 1 equals 2, times it by 100, which is 200% change. Same thing for this next one. I'm going to go stat, edit. My x's are all the same, I just need to change my y's. Then I go stat, calc, 0. This one I'm going to round. Wait, I've done something wrong. This should be 0.8. Stat, calc, 0. Ah, much better. So, my initial value is 0.8. My growth factor is 2.1. If I'm given a table of values, my initial value should always be the one with 0. So that's how I knew I did something wrong. Then to find my percent change, I do 2.1 minus 1, which gives me 1.1, times by 100 is 110% change. These ones want me to graph and answer the following questions, so I'm going to graph on my calculator. I have 3 e to the negative 0.8x. So I'm just going to sketch this over here. Ooh, sorry. Okay, so my domain is going to be negative infinity to infinity. Again, this might be shown as all real numbers. My range is my y values, so it gets really close to 0, but it never actually touches, so 0 to infinity, or y is greater than 0. My x-intercept is where it's crossing my I think it means to say y-intercept. It's where it's crossing my x-axis. So if I go to my table, this is 0, 3. My equation of my asymptote is going to be y equals 0. Same thing for number 9. I have 4 to the x minus 1 plus 3. Graph that. Again, this one's going left and right forever, so negative infinity to infinity, or all real numbers. my range is getting really close to this line. If I don't know what that is, I can take a look at my equation. That plus 3 is going to be it. So this is going to be 3 to infinity, or y is greater than 3. Again, this should be a y-intercept, and it's crossing at, if I go to my table, 3.25. My equation of my asymptote is that line I'm avoiding, so y equals 3.